Hey everyone. So let's get to it. What is human trafficking? Human trafficking is the coercion of making people do work that they otherwise would not be doing. So that includes farm labor, in-home labor. It could also include escort services, which is mainly the focus of this talk. Some statistics around human trafficking. Globally, it's a $150 billion industry, which means that it makes it into the top 5 illegal industries worldwide. 75% of the people being human trafficked are female, and 25% are children. But that is not the scariest statistic, in my opinion. This is. So in 2007, 40.3 million people were global victims. But if you compare that to the number of victims and traffickers identified and rescued, it's tiny. So that brings up the question, why is such a gap? 2 answers I can think of. One is because the government, which is usually the entity that's fighting this because it's an illegal industry and crime, it's still evolving to embrace the technology that would help it fight human trafficking. Just in April, earlier this year, the US government signed into law SESTA and FOSTA, which took down key websites on which human trafficking was occurring. But what that does is it plays a sort of whack-a-mole because the people don't go away. They don't become rescued just because their number 1 platform is taken down. They just move to another platform. And then people who gather data on human trafficking happening now have to evolve their technologies to make sure we're tracking where the traffic is going and then scrape those sites. So for the short term, it's helpful, but not for the long term. So that's one reason. And then the second reason that this gap is so hard to close is because oftentimes a person from the United States will travel abroad and find people who are suffering and in distress and approach them and say, hey, I can take you to America. I'd give you prosperity. I'll give you safety. I know that you have a really hard family situation, so just come with me. And that's not what happens. Then these people are barred from learning the language of the country they come to. They're very isolated in their environments. And oftentimes they come from places that don't have rights. So how would they feel empowered to be able to reach out and say, help me? They oftentimes don't. Enter Global Emancipation Network. Global Emancipation Network is a Washington nonprofit company that aims to combat human trafficking of all types, but currently starting at the sex trafficking level. And we do this by gathering data of people that are being bought and sold online, and then providing an easy way for law enforcement and other NGOs that are doing rescues to search it as quickly as possible so they can identify those networks. So Global Emancipation aims to be the one-stop shop for data of human trafficking that's going on. But Global Emancipation Network does not do the rescues. And who am I? I'm Amelia. I'm a software engineer at Global Emancipation Network. And I have had the privilege of being the only software engineer hired as part of Global Emancipation Network for the Minerva release, which we'll talk about, which happened at the end of September. I also am one half of Vanderwerf Consulting, always looking for projects to take on. And here's Minerva. Unfortunately, this is all I can show you. Yeah, thank you. But I thought it would be more fun if we visualize use cases to try to understand why Minerva is so cool. So, say I'm a law enforcement official, and say I have a suspicious phone number, Or I have a suspicious Facebook handle, or Twitter handle, or email address, or name. And I think this identification information might be associated with human trafficking. So what do? I log into Minerva, and in its Google-like search bar, I can type in the identifying information that I have. Bam. And then Minerva will give me, say, 50 results that contains ads where this particular phone number was used in advertising, or it can give me user profiles where this phone number was the main contact information for that person, or reviews about experiences that somebody who had purchased the service had with the person, or threads where general discussion is going on. So, but even more interestingly, if I click on one of those ads, I can see the text of how that person was advertised. I can see the images posted in that ad. And if I scroll down even more, I see similar records. Records that have the same title, or the same phone number, or a person who looks very similar to the person featured in the ad. So I can click on those, and out pops this chain of trafficking. So that's one. Two, let's say, again, I'm a law enforcement official, and a family has filed a missing persons claim because their daughter has been missing for over a week, and there's a high likelihood that she was gathered in by one of these rings of traffickers. So what I can do is I can take the photo I have of the missing girl and upload it into Minerva. And then Minerva will cross-check the database of facial recognition data and see who most matches that face, and then can continue investigating from there. That could lead to other phone numbers or other identifying information. Or another tip-off of human trafficking is if somebody is traveling often. So say this photo is uploaded and it brings back 10 hits, and 2 of those hits are from Seattle, 2 are from Portland, 2 are from LA, etc. That could be suspicious and could even help in a rescue, knowing if there's a pattern of movement. And then lastly, another use case. Say I'm a law enforcement official and I've been assigned 25% of my time. I have to work on busting human trafficking. But I don't really know where to start, because right now I don't have any leads. So say I work for the LA Police Department. In Minerva, I can just enter Los Angeles and the predicted age of the person, because we run all images through age prediction software. And if a person is 17 or younger, that's a case immediately. Hit search, bam, there are my results. So you may be wondering, how is this all possible? It's pretty cool. So the rest of this presentation will be about the architectural stack. Here's a very simplified diagram. I will be drawing more details. So on my right, we have the Backend and then Splunk database middle layer, and then on the left, we have Minerva, the web app. So the Backend. All right. So here are our sites of interest. I had mentioned Backpage and Craigslist as part of Sesta Fosta takedown. So these are Backpage and Craigslist. And here is our timer. Once a day, an Azure function is spawned and crawls each of these sites. And it is looking for URLs to interesting data, that interesting data being ads, threads, user profiles, etc. And it puts that onto a queue. Queues are cool because they allow for easy parallelization. So as soon as that URL is placed on a queue, there are other Azure functions that are spun up quickly to then go out and download the HTML and the image data that is so crucial, and then puts it into an Azure Blob store where we store all of the raw data. One other piece is that at this stage, it makes most sense to do the phone number extraction. It's quite a complicated problem to extract phone numbers. And the reason being because we have to support all different countries, formats. But that part's pretty easy. Google has this cool library, libphone number. You can just use it. But the hard part is that in these operations, traffickers like to obscure their phone numbers. So think of a phone number where you have a different emoji inserted in between the numbers. Or if you replace some of the numbers with words, like the word 3. Or if you replace it with a word that sounds similar to a number, or use exclamation points instead of eyes, etc. It can get really complex really quickly. So we add that. So this piece, which is the web crawler, Global Emancipation Network has been very fortunate to team up with another team, Seattle Against Slavery, to co-write this piece. And Seattle Against Slavery also has an anti-human trafficking approach. What they mostly do is they gather phone numbers and then they send out texts to the phone numbers to try to elicit responses and see if they could meet that person individually and rescue them. So here's our web crawler. And let's transition to the data pipeline. That's where the cool stuff happens, like age prediction. So as part of these Azure functions that download the HTML and the image data, they also put another message onto a queue that then feeds our data pipeline. So here's the queue. Here's another Azure function that's spun up by Global Emancipation Network's data pipeline. The purpose of this function is to reach out to the other services that we use. Like, here we have a Deep Vision API call, and what that does is image tagging. So if there's a house in the picture, we'll know that. It'll return that as a JSON, as well as the age prediction. And also, as part of Deep Vision, we have that facial recognition database. So the images are queried and uploaded to the facial recognition database. And then later on in the stack, at the Minerva level, Minerva will reach into this database and pull the raw images from here to display them to the user on the screen. So I'll talk about challenges as well. Challenges. One of the challenges of web crawling in general is that sites are getting good at detecting if you're a bot or if you're a human user. Some go even as far as to put in CAPTCHAs, Google CAPTCHAs. That's the best algorithm in the world. What can you do? So we try to get around that by using the Azure Function infrastructure. And what's cool about Azure Functions is when you spin up a new function in a geographic region, it'll give you a new IP address. And so it's much harder for the sites to figure out if you're a bot if you get one request every 30 seconds from an IP address. Usually they're more lenient, depending on how aggressive the bot detector is. So go ahead. Are you saying how within the crawler do we detect if it's data that we actually want to ingest?
Yes.
Yeah, that's a good question. So there are sites that are specifically dedicated to escort services, and those are not Craigslist and not Backpage. I don't think I can name them. So in those situations, we just crawl everything, at least on the first ingest. On subsequent ingests, we crawl as much as makes sense for the 24-hour time frame. But in the cases of Backpage and Craigslist, we know which sub-URLs have the lists of ads, and then we just start there at the web crawling point. And if those change at some point, it would be a manual update. But good question. So I talked about bot detection. And another challenge that we have faced is the fact that Azure functions are serverless. They're awesome. You don't have to manage a VM to spin them up. They're just like little programs that run in the cloud. You can run and forget. But the problem with that is that it's very hard to render the JavaScript that is associated with so many pages. Like some pages have images that they inject only with JavaScript. So if you're just doing an HTTP request, you don't get that information. And if we wanted an architecture that did also enable the JavaScript to run on the page, we would have to use a headless browser and then control the browser with our crawler. But we'd have to give up the Azure Functions infrastructure. And we'd have to go to something with managed hardware, like a rack of VMs that have different IP addresses and can scale out as much as we need to. So give and take there. So we left off with all of this data that's generated. So there's the raw HTML, raw images. Those get put into Blob Store. Then we have metadata about them, like when we crawled it, headers that are important, or what the URL was. Or since we're storing the text, the HTML, and the images separately, we need to link them back together. So that's also in the metadata. And so I'll put an arrow right here from the data pipeline, from the backend. And this is Splunk, S for Splunk. So what Splunk receives in that transition point between the backend and the middleware is these data definitions. So we have one for the HTML object. We have one for each image. And then we have one from analyses like Deep Vision, which does the image tagging and the age prediction. They're big JSONs. They get ingested into Splunk. So the challenge here becomes, how do we search on these easily? Because a user, when they're in Minerva, they want to search by age prediction. That's over here. But they also might want to search by phone number. That's over here. So the search would end up being a big, messy join, unless we add a summary index layer. So what a summary index does is every 5 minutes, it runs and pre-joins all of the data into a new index that's searchable on all the parameters that we want. So this phone number comes down, and that becomes a column. This age prediction comes down, and that becomes a column. A geographic location comes down, and that becomes a column. A hash of the image. Hash is important because with a hash, you can determine image similarity using a Hamming distance algorithm. If they're less than a certain amount apart, the image hashes, then that image could be very similar. It could be the same person, but with the little bunny ears that iPhones so nicely produce as a layover on top of images. All these items get put into the summary index, and then Minerva searches on them. So that's one thing that happens in Splunk. Another thing is because Splunk is a pretty cool database. It's more than just a database. It can enrich data by servicing its own HTTP requests, going out to Newstar. And Newstar is really awesome because if you send a phone number in an HTTP request to Newstar's API, it will give you back the address associated with that phone number, as well as personal names. So that can be a key point in locating a trafficker's residence. Similarly, with geocoordinates, at this point, with this text, with this HTML JSON element, in Splunk, the geographic location of where the ad was posted is extracted. But in Minerva, we want to have a cool little map with little map markers that you can click on and navigate to the ad. But in order to do that, we need geocoordinates. So we reach out to the Google API and get geocoordinates back. And also, Splunk, I talked about extracting the phone number as part of the crawler. And Splunk continues to do the extraction of email addresses, titles of the ad, things like that that we would love to show the user in the UI, in Minerva's UI. All right. And the front end, woohoo. So Minerva sits here, and the user behind the computer. And to do all of its searches, it reaches out to Splunk. Mostly the summary index, sometimes the individual indexes that contain the HTML data definitions as it needs to. Furthermore, crafting a unique and special Splunk query will give you those similar ad searches. The scrolling down to the bottom of the page, trying to identify the networks by seeing ads that are similar to the one that I'm looking at. And then it also, say a user clicks on an image and wants to view the details of that image. Minerva will query out to the facial recognition database. Technically, it's a service, and ask, give me URLs of images that this person looks like. And we get those back, display them to the user. So I touched on image upload as well. Minerva has the image upload service where a law enforcement official can take image of a missing person, ingest it into Minerva, and then it gets processed and analyzed with image tagging and age prediction, as well as gets placed into the facial recognition database. So since the infrastructure in the data pipeline is already built out, how that happens is when a user uploads an image, Minerva will put it onto a queue, and from that queue, an Azure function is automatically spun up from the data pipeline and processes it, puts it back into Splunk, and then Minerva can query on it, and the user can see all of the results. So one of the challenges we have had with using Splunk as the main searching mechanism is that for certain searches, it is slower than we have wanted. And I think it helps to know about Splunk architecture in order to explain why that is. So Splunk is a real-time database. It's built for real-time, constantly coming in data. Like for log data, it's great for searching through logs. And because of that, it doesn't have the ability to index on every column, or it doesn't even have columns, which would be helpful for us since we have so many different parameters like location or type of site Like if you're searching for Craigslist, there are so many hits of Craigslist. And let's go back to that Bloom filter. I'll explain more. So a Bloom filter is a probabilistic data structure that will tell you whether or not data or a word in a bucket is present in that bucket. So say you have Craigslist. So here's your bucket of data. That's 1 hour's worth of all the data that Splunk received. And it has Craigslist as a word in it. And it has a phone number. So here's the phone number. Phone number is pretty unique. So if that Craigslist maps to this index in a Bloom filter, then it will have a 1, which means that that word Craigslist is present, and the phone number as well. So if we have a lot of these Bloom filters that represent each bucket, we're going to be seeing a lot of 1s for Craigslist. And we're going to be seeing only a few 1s for this phone number. So if a user's only search criteria is Craigslist, then what Splunk does is it looks at all the Bloom filters, sees, oh man, I have a lot of buckets to open up, and then opens them up each one chronologically. And when that gets hard, when it gets difficult is when SESTA and FOSTA come up. The latest data we have is from April. So it has to search through millions and millions of records to finally get that result. And the reason that sometimes Craigslist, that word, could be in other Bloom filters that are earlier is because sites can cross-reference. Like sometimes like if this word is in the HTML. I don't think I explained that right. Anyway, our searches take 10 to 15 seconds, which is pretty not acceptable. And I would say that a good solution for that would be to integrate a layer of SQL on top. It's this hard problem because we want to use SQL because it can index on columns and have structured columns. But then again, we have so much processing that's done on the Splunk side. So we'll have to balance that. So this is a Forbes article that was written just a few weeks after release. And it features our founder, Sherry Caltagirone, right here. And this is why I was part of Global Emancipation Network. 989 individual victims and perpetrators identified, tracking 22,000 more. If you go back to the slide with 2017 data, then you'll know that 15,500 globally were identified. And in a short period of time, we got almost 1,000 tracking more than that. And this is only data that's public. There's much more that I can't share with you. So I'm really excited. And honestly, it's only the tip of the iceberg. We're only scraping a handful of sites. We're only, for this Minerva release, we're really focusing on US data, not going completely globally yet. So all of that is on the horizon, and the infrastructure is there. But you may be asking, what's next? I already touched on more data in order to keep the engine of saving people going. Another cool thing would be to have a stable revenue stream. And something that would accomplish that is having a commercial API. Because, Facebook and Bank of America, et cetera, don't want to point and click in Minerva. That's really more geared for law enforcement. So what they would like to do, or what we would like to do, is to have an API that can handle thousands and thousands and thousands of requests. And that would bring actual customers who would pay for use. And the reason that this is a necessary service that they would like is because Facebook, they have a liability that they are not advertising trafficking-related content. And so if they can outsource that to a professional, which would be Global Emancipation Network, that would put their minds at ease. So, and then the third is a classifier. Something law enforcement would love is to order results that they see by probability that that content is associated with trafficking. So with that would involve an algorithm that would take into account all of the pieces that have historically been known to be associated with trafficking, like one phone number advertising 10 different people in a facial recognition database, or movement that we touched on, and then calculating some percentage of probability from that. And that could make the time to rescue a lot shorter if we had that. So all in all, it's made me very grateful to be working with Global Emancipation for 2 years, and even more grateful to all sponsors. Questions? Very good question. Yes, we do have a table of URLs which we have already seen that we save. So that protects against crawling the same exact page, but oftentimes people copy and paste. And so we get all of the copy and pasted items that are posted multiple times. So, but that adds to a case. Yeah.
So, number one, how did you get involved in this project? Two, is this like a volunteer effort? Like, how is this the maintenance of Minerva managed? And three, I'm not familiar with any of this trafficking, but is it true that are there blatant Craigslist ads that say somebody's for sale? I mean, is it that blatant? I don't know.
Yeah, good questions. So firstly, how did I get involved? I attended University of Portland in Portland, Oregon, and the technical director and the executive director, they came and presented at University of Portland, and that was my way in, just inspired by that. Second question, volunteering. The organization is primarily volunteer. I started as a volunteer. It actually was perfect because I was in the process of having my second kid, and I couldn't work, so this was perfect. It helped me become a full stack developer while still not having to commit to full-time work. And then after some time, I was hired on because they received a really generous grant that was able to do that. And then the third question was about selling people. So usually what these ads look like is new in town, this person would love to take you on a thrill journey, call this number. Prices aren't listed, and then the pictures are definitely suggestive of the type of service.
It's not blatant, but there's like a code language
right.
that communicates that it's a traffic.
Right. Exactly.
Thank you for what you're doing.
Yeah. Questions?
First of all, great presentation. And, thank you very much for what you're doing.
And say your name too, please.
My name is Jared.
Okay. So.
And my question is about once you've aggregated a bunch of data with a particular person, now you have personally identifiable information, their history, so to speak. Just to say, with GDPR, for example, after a rescue, they might want to request that you delete all of their data. Or maybe you want to suggest that to them.
That's a really good question. Yeah, I don't think we've built the security model around types of data access, like certain people can't see data from this site, or certain people can't see images at all. But we haven't thought about that scenario. That's a really good one. I'll have to think about that some more. I can imagine with Splunk it's hard because data, the JSON data that's stored in it is immutable. And so you have to reprocess data if you want to get it back. But with SQL, it'd be simple to add an extra column. And that's going to be the direction, the future of the architecture. Good question.
Steven, you mentioned geotagging. Do you go through geotag filters on images as well? So I know that embedded in some images, you probably grab platforms, and so coordinating with that. I didn't know if you included that versus just possibly indication of where someone's saying something.
Yeah, that's a really good question. So 2 parts to that. We're focusing on geographic information associated with the ad, because usually how these sites are structured is you would have ads for New York City or ads for LA. So you can easily extract the location that way. But every single one of these sites that I have encountered, they scrub what's called the EXIF data, and that's the metadata in the image. So we do not have access to that, and I assume that these websites are intentionally doing that for privacy reasons. But if a user uploads an image, then we would have the EXIF data, and we do have algorithms in place to extract the important data from that. Good question. Ben?
Yes, okay. I'm curious if you could talk to the decision to use Splunk. It's a
Right.
very interesting technology, but it's primarily used for logs. It's a kind of novel use case. So yeah, just interested how that came about.
I'm glad you asked. So with a nonprofit, the constraint is usually finances. And
it's paid for too, and it's being typically, right?
right, and actually I should have included, I did include Splunk as a sponsor. So what Splunk did was donate an engineer's time, a certain number of hours per week, as well as the technology itself, and established a partner relationship. So that's primarily the reason. I think it was the latter. But even if we integrate SQL, there are so many queries that we would want to send to Splunk. So it's more of a division of labor, user-defined queries, where perhaps most of what's going on in the search bar that law enforcement types, that could be primarily sent to SQL. And then to Splunk, what they would specialize in is data over time, like seeing how much traffic is being posted on one site versus another. Like Splunk is so flexible, and it generates graphs for you, which is nice. You can just embed them as iframes in Minerva. Makes it easy.
I'm curious more, you touched on it a little bit, but on like the sort of scraping side of things and how you like actually store a snapshot of like the site. I guess I'm curious if you did, or if you can tell us or not, if you did end up going with something like a headless browser or something that does end up rendering JavaScript, or just like what actually comes back from the HTTP request, and then like what the best way, I guess, like how would you decide and like when when the HTML is like appropriate to like, you know, if you're rendering JavaScript to like snapshot it, and then do you save it all raw? Do you like extract certain things out of it, that kind of stuff?
Right. So a couple parts to the question. Yeah. So one is like best practices for web scraping. And then the second is what information do we store raw and what do we extract from it, right?
Mostly about like where you ended up on like sort of the just request versus JavaScript, and then also like, just sort of more information about how like the soup of HTML sort of becomes like useful for you in the future.
Right. So first question, where we're at right now, we're at the HTTP request only stage. not doing too much with JavaScript, and the limitation there is the Azure functions because they have no managed hardware infrastructure that you can rely on underneath. They're not like virtual machines where you control the hardware itself. And you control what is installed on the machine. So we don't have the ability right now to install a headless browser, but that's something that is rising to the priority list as more and more sites are onboarded that we'll definitely look at. It's not necessary for every single website, because some websites are just plain and simple, you can get by with HTTP requests. Others are like, you can't see any images unless you render the JavaScript. So those would be the ones at the top priority. And then second question about extraction from the HTML. Right now, we're relying on HTML tags to get important things out, like title or geographic location. Not phone number as much. There's a abstraction algorithm for that because we can somewhat recognize formats of phone numbers unless they're too obscured. But the ideal that we would love to have is to have abstraction algorithms that can look at any page and extract the geographic location. And we have played around with natural language processing and integrating that. So it can be hard too because the boilerplate of HTML pages, all the excess stuff around what you actually want can suggest like, hey, LA is close to where you are right now, but we're not looking at LA, and so.
Are the sites that are they all public?
Yes.
Or are any of them like walled off and you have to get past some kind of like authentication thing at all?
So most of them are public. You could go there if you knew the names. There is one that does require authentication, and that one has been harder to scrape. We also did some investigation into what's out there in the dark web, and what we discovered is that at the current point where there are anti-human trafficking laws in place, but not as enforced, people have not been pushed to go underground yet. So most of the data is out there for you.
For your APIs in the future, I know that some organizations would probably be helpful to pay for it, but I also know that there would probably be a segment of organizations that would want a free API and you can hit and like give new information. But like so you don't need to scrape me. If something brings this problem, I'll feel free to send you this person your way. So you might want to look at dual track of a more robust API for someone trying to vet versus someone else who's just more than willing to share to donate, essentially saying, if I found like user bases who are like, yeah, we don't really know who these users are, but I'm more than happy to say, we send information over, or even not announce it just so you can get a feed without a scrape. And you might just get secondary sources of information where a phone number is already flagged. And you can say someone's unflagged phone number popped up on some other random site to gather other contact information.
Right. That's a really good idea. I think the goal is to have the platform be free for law enforcement, so at least they would get it for free. But yeah, an alerts and notification system is also high on the priority list to build out. Yeah. Tim?
So you mentioned that those two laws that
SESTA and FOSTA.
yeah, and they closed down effectively, it sounds like Backend and Craigslist sections. So did that really mean that basically, like Craigslist I know is so plain and it's rendering the site, it's mostly HTML. Did they just like shut down the ones that were easy for you to scrape essentially?
Yes, Craigslist.
Did they name specifically in those laws?
Yes.
Okay.
So I believe still, if you go to backpage.com, they'll have a nice government imprint, this site has been shut down for that purpose. But yes, they were both highly trafficked as well as relatively easy to scrape. So us and other organizations that do similar tech-based data searching were hit pretty hard. Then you have to start from scratch. Like, which ones have the most traffic?
Maybe I guess, did you talk about timeline? Like how long this organization can run and how long did it build? How long did it take to build?
Yeah. Very good question. So this organization is about 2.5 years old. I was brought on about 6 months in, so I've been there for 2 years. For that first year, I was a volunteer staying at home, stay-at-home mom. And then after that, I was hired on for approximately 8 months full-time until the end of September, which is when the release happened. And now I'm very part-time, depending on finances and also consulting. So.
And the follow-up is, so
Yeah.
you mentioned Splunk was generating or providing, development support as well. So were like all the partners sort of contributing in that way. I mean, how big is the team?
Just on the global emancipation side.
Just helping with that, either, I assume like Microsoft providing software support as well.
Good question. Yeah, so we use a lot of Microsoft technologies. There's one volunteer that is a architect at Microsoft that helps us figure out how to piece